Hi class, this is problem 3.5, predicting the arrangement of electron groups around the central atom of a molecule. So they want to know the question for the shape of the cyanate ions. And so they want to know how many electron groups are around the central atom. Okay, so let's just solve the Lewis structure for this. So we have, for the Lewis structure, we need the total of valence electrons. So we have oxygen and carbon and nitrogen. Oxygen is in group 6A, so it has 6 valence electrons. Carbon's in 4A in the periodic table, so it has 4. Nitrogen is in 5A, so it has 5. And then there's a negative charge on this thing, so it's going to have a 1. An extra electron for that. So we're going to have a total of 16 electrons. Okay, so we'll take those 16 electrons and we'll spread out the molecules, or the atoms, excuse me. Okay, and so we'll put 2 electrons there. Excuse me, we'll do this again. So we're going to put 2 electrons there, 2 electrons here, and so then that's 16 minus 4 is 12 electrons left. Okay, and then we can surround them around these guys. So we're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you do the outer electrons, outer atoms first. So that's 12 minus 12 electrons used, that's 0. So we've used them all up. But we're not at an octet for the carbon. So we have octet for the nitrogen. So there's 2, 4, 6, 8. And 2, 4, 6, 8 for the oxygen, but carbon has 2 and 4, so we need to move some bonds. So here's, we'll draw on it again. Okay, so we have what we want to do is move the electrons to make a double bond. So we'll scratch this one, and that'll go into here to make a double bond, but we're still not in an octet. So we have 2 options, and the cell is actually going to vary between the 2 options. One of them, we can put the negative charge there, so it's equal, but that's technically not correct because oxygen is more liking of electrons. So if the top 3 atoms are fluorine, oxygen, nitrogen, who like the electrons the most, who are most electron negative. So oxygen is more electronegative than nitrogen, so it's going to have a charge on it. Okay, so we really want to do carbon and nitrogen and oxygen, and so we'll go back to the start of this. Okay, so we move this 2 to here, and we'll move this 2 to here. And so then this will be the minus charge on this guy here. So then this gives us an octet. So 1, 2, 3, 4, 5, 6, 7, 8. That's fine. Carbon has 2, 4, 6, 8. That's fine. And 1, 2, 3, 4, 5, 6, 7, 8. That's fine here. Okay, so this bears the charge. So the final charge of this is going to be it's going to look like this. Let me get this cleared up. So OCN okay, and then to figure out how many groups of electrons, so we only have one group because a single bond, double bond, or triple bond, it counts as one group, as well as unpaired electrons, and this is the second one. So 2 of those groups will give you a linear shape. So the answer is 2 and linear shape. All right, let us know if you have any questions. Thanks.